So we will implement polymorphism using function overloading. We have covered in the previous tutorial operator overloading, and we know that polymorphism is a way to process data differently using a same name. Processing data differently using same name. So we know what is the meaning of polymorphism, but in this chapter we will see how polymorphism is implemented using function overloading. So let me define what is function overloading. So function overloading is creating functions with the same name, but different parameters, or you can say different arguments. So I will write parameters slash arguments. So let's see how we can implement function overloading by creating a program. Before creating a program, let's look into its logic. So we will create 3 functions, and these 3 functions have the same name, and they should have same return type also. So we are going to create 3 functions with the same name, but we are going to use different parameters in each case. So in the first case, we will just calculate the area of the square. So we will just need an integer variable here. So this is the function prototype of all the functions that are in our program. So the second one will calculate the area of the rectangle. So we need 2 parameters here. The next one will just display the area of some other, we can say that, let's suppose triangle. So in case of triangle, we will need 2 variables. We will need the base and height. So if it is a right angle triangle, we will need the base and the height of the triangle, and the formula is half into base into height. So we know that the base and height are the 2 parameters that we will need. So we will write int comma int. But in function overloading, one thing you need to remember is you cannot create 2 functions with the same type of arguments. You will have to use different parameters or arguments, or different number of parameters or argument. You can see that in our first case it is 1, in the second case it is 2, and in the third case it is 3. So this is the common mistake that programmers will make. You cannot overload a function with the same name and having the same type of arguments, even the same number of arguments. So you can use these 2. So what we will do is, at the time of function call, so how does our compiler knows, or how does, at the time of function call, how will our compiler know which is the right match. For example, I am calling the function area 5. So function overloading is checked at the time of execution. And in this case, you can see here that we are calling the function area with an integer parameter 1. So this will get matched with this function. So let's suppose you have a big program and you have a lot of functions in it which have the same name. Let's say the name is area, but they all have different number of parameters. Let's suppose they have different number of parameters. So all these functions will be called, or you can say that this will be matched with the same number of arguments. So if we are using area 5, the function that accepts only one argument will be called. You cannot call this function. So this is in the int main function. This is inside the int main function. This is the function call. So this will just call function area, which will just copy the value and it will just display the square of the number. So this is the area of square. So this function call will call the function by matching the number of the parameters and also the data type of the parameter. So let's suppose now I am calling another function, but this time I am writing 2 parameters here. In such a case, this function will not call, so this function call will not go to this function. It will go to our another function which accepts 2 parameters, and we will display the area of the rectangle. So now we know that functions are being overloaded by using different number of parameters. So this is one way to overload our functions. The second way to overload our functions is to use, we can use same number of parameters but all having different data types. So what will happen if I will just create a function area with just one parameter float. So we know that there is already a function that accepts integer value. But what will happen if we will create the same number of parameters? See, this is just one parameter and here also it is one parameter. But now the data types are different. So when the data types are different, it will also be checked at the time of function call. So if we are going to call function area 5.7, this function call will not go to this one. It will check the number of parameters as well as data type, and then it will go to the function area float b, and then it will display the output b square. So this is the second way of overloading the function. See, we are processing data differently using the same name. In the first case, we are using say different number of parameters, but they have same data type. So this is function overloading. The second way is we are using the same number of parameters but with different data type. So this is also another way to implement function overloading. There is also one more thing that I want to say. Let's suppose I make another function call, and this time I am calling the function area, but I am using a character value as an input. We know that there is no function here that accepts character values. So we know that there is no such function here. We have not even defined any function with character type. But if we are calling this function, if this is a function called area C, it will do a conversion of this data. It will convert it into integer format. So we know that there are the values, or you can say the characters A, B, C, D and so on, and A, B, capital C, capital D. These are some of the characters in C++, and these characters correspond to some integer values. So these have some integer values which are also known as ASCII values. So it's very simple here. It's not difficult to understand. Each character has some integer value. So if you want to represent a character, it will have some integer value. So when you will call this function, this will automatically convert this data into integer data. So this is another form of function overloading, and we will implement this whole example in our C-line IDE. And one more concept that I want to discuss is the concept of default arguments. So the concept of default arguments means that instead of writing these prototypes, or you can say instead of defining the function more than one time, like we are going to define a function that accepts only one parameter, then we will have to create another one which have two parameters. So instead of doing it again and again, we will just define one function area, and it will accept one integer. But if we are calling function with some other arguments, let's say there are two arguments, so we will write int b equals to 3, int c equals to 4. So let's suppose this is our function. So let's move on to the first function call again, area 5. So this function area 5 will call this function void area, which will give value of 5 to a, and these two are known as default arguments. So these are the default arguments. But what will happen if we will call this one, area 5 comma 6? So the value of a will become 5 as usual, and this default argument will get changed because we are providing some other value to it. So now the value of b will not be 3, it will become 6, but the value of c will remain 4. So this is just a simple concept to explain the use of default arguments in function overloading. So let's implement this example in our C-line IDE and see how actually this function overloading concept works. So let's now first write the function prototype of area function. So let's suppose the first one is the area and int value. So this is the function prototype. And now we're going to create another function with the same name, area, but we are going to overload this function, so we will use different parameter. So void area with different parameter. We know the next way to overload a function is to use a different data type. So we will use this as a different data type. So these are the three ways how we can overload a function. So we are not using default cases. We are not going to use the default arguments in this example. We are going to implement these three functions separately, and then in the next program we will just use the default arguments. So let's just call the function, make some function calls in the main function. So the first one is area 5. Next function call will be area, let's make it 6.7, then area 7,8. So these are the three function calls that we are doing here. So what I'm just going to do here is, let me define the actual functions. So for the first one, we will just do this simple thing, and we will just display area of square. So area of square is a into a. So this is the first function, and let us now overload this function area by using some different parameters, different number of parameters. You can also use int a comma b, and now we will just type area of rectangle, and we will just multiply the length and breadth of this rectangle. The next one is using different data type. So we will create a value float f, and we will just write cout area of square. I'll write float here to represent that the function call is of float. So we will just write f into f. So these are the three function calls, and you can see here that in these two we are using different data types. So this is now expected function body after function declarator. Okay, so this is the error here, which should be okay. So it has been removed. So this is just a way to implement function overloading. So we will not write these three functions in the same. Let's just call function area 5 and let's see what will be the result, or let's just implement all of them and see the order of the result. So after running this program, we can see that there are some errors. This error says that call of overloaded area double is ambiguous. So this function call area 6.7 is ambiguous because 6.7 is a double value, and since there is no double, there is no function prototype that uses double as an an input, so we will have to change it to double value, and here also we will have to write double, and here also it should be double. So if you will call some function which is you can see that in this case it is an ambiguous, so because the compiler was not able to find an exact match of this function call, because this was a double value and it was not able, the compiler was not able to find a function that matches this. So this we have make double, and after making it double, let's see what will be the program, what will be the output of this program. So now this program has got no errors in it, and you can see here that in function area 5 it is matched with this function with the same parameter. So the area is 25. The next one is area of square, and since it was a double value, the call has, this function call has matched with this one. So now this is the area of rectangle 56. So in this way you can overload functions. So this is not, we are not using default arguments. So let's now edit this program and use default arguments. For the default arguments, we will just remove these values, and instead of writing two functions we will just write one function, and we will just make one of the parameters as a default argument. So if this function call will call this function with which will assign value of a as 5 and the value of b will be 6, and this function call will call this function, the same function, but the value of a will be 7 and the value of b will not be 6, it will be 8. So there will be a change in the function prototype also. We do not need this function prototype now. So you can see how the program has become concise and compact by using default arguments, but there are some cases where we do not want to use default arguments, so you will have to write all the overloaded functions. So in this way we implement polymorphism, object oriented concept in our program. So let's now run this program and see what will be the result. So you can see here that we have got another error. So this error say too few arguments for function void area int. The reason behind this error is that we have written a function prototype here which accepts two integers as input, but here we are calling function 5 which takes only one input value. So that's why too few arguments. There is one argument instead of two. So if you want to write a function prototype in a default argument case, you will have to write the variables here, and you will just assign, you will just say that the second variable is a default argument. So if the function call is area 5, it will call this function with a equals to 5 and b equals to 6. So let's now run this program and see the output. So when you're running this program, there is another error. It says default argument given for parameter 2 of void area this. So here is an error, so which says that you cannot assign default argument here. So we will again run this program and see the output. So now there is no error in the output. You can see here that there are no errors. So we now know that when can we make errors and how can we resolve them in case of default arguments, and how we should be careful in just assigning the function calls and making the function and the prototype in case of function overloading, or else you will land up in creating a lot of errors in your program. So this is how function overloading is implemented, and you can see the output is as expected. The 5 value of a is 5 and 5, and then the b will be 6 because it is default, so 5 into 6 will be 30, but in the next case it will be 7 and 8, so we will override this value. We will not use the value of b as 6, so 7 into 8 is 56. So this is how function overloading is done in C.